Okay, so data centers have been making fairly significant progress in terms of their sort of path to net zero. But then this thing called AI sort of comes along and I won't say destroys it, but it certainly challenges it because obviously they're very power hungry compute. So yeah, just your thoughts as to sort of the progress that was being made and how AI does or doesn't disrupt that progress.
Yeah, thank you. Thank you for that question, Philip. Definitively, we are changing the scale. We're changing the speed and we're changing the size of this race. I mean, it's what we can see is that the race to bigger, larger, more data centers is an energy race. It's a race for the electricity, a race for the power, and we're talking about the need of electricity, but also the need of cooling. So we see that from Mitsubishi Power, from our Mitsubishi Heavy Industries group, that the demand of electricity is unprecedented, caused by the data centers and by the AI that is disrupting and appearing, and it's just the start. It's just the start, and we see because we have these capabilities both for power generation and cooling purposes that we see that we're going to be crazy busy. We're going to be crazy busy, and this is one lifetime opportunity for us at Mitsubishi, but for the society, all of us, we are going to have to benefit from this decision that we have made. We need more data, we need smarter, we need faster, we need more reliable, and that's again, Philip, is just the start.
Yeah, I mean, I think I've seen predictions vary, but I think it could be 5% plus of sort of total electricity generated across the world will be consumed by data centers, which sounds quite, I won't say alarming, but quite significant. And clearly, I mean, you alluded there to the fact that there's a more general electrification going on. Europe, perhaps, if we're generous, say it has an aging power and infrastructure, so there's that problem. And then I guess predicting the future. So just, I suppose, how complicated and how worrying a situation are we facing, I suppose?
I mean, the humankind, our society has always managed to overcome the challenges. So in that sense, I'm quite positive and optimistic to the prediction of the future that you mentioned, Philip. Definitively on the numbers in the UK and European Union, I mean, we have like over 2% of the electricity today is being used for data centers. So we all can see that in the coming 5 years, so up to 2030, that's gonna multiply by 10. So it's gonna be way above the 5% that is being told, because of course we are in that ramping up. And we're talking about numbers like 28% of the electricity coming to data centers in the European, Western European region. So we look at the US. The US is forecasting between 50 to 150 gigawatts of new power just for the data centers in the coming 5 years. We're always, I mean, I'm a kind of seasoned engineer for more than 25 years in the business. We always talk about 10 years later, 20 years later. Frankly, Philip, in the last couple of years or in the last 12 months, we only talk what's going to happen in the coming 2 to 5 years, because it's very tangible. It's very tangible. It's orders are coming. I mean, that's very important. So it's not predictions. It's really investments and regulations behind this happening. But yeah, we are in a total revolution driven by three factors. One is, you mentioned, electrification. So we are electrifying, we're making things smarter, which we cannot forget. To electrify things that are not electrified today, you need a lot more electricity. It sounds like a very silly sentence, but well, it's quite a very obvious thing which is forgotten, that we need to generate a lot more electricity for that reason. Then we need to decarbonize. So everything, every new electricity that we deliver needs to be decarbonized or more decarbonized than what is existing. So we are tripling the installed solar globally in the coming 5+ years, and we are doubling the wind power. So these two technologies are extremely smart and clean and amazing, and they need backup for the times that they are not available to be providing that electricity. And let's not forget, or let me highlight that data centers and AI storage, machine learning, they need 99.9 period availability of electricity. So you cannot be exposed to disruptions, outages, etc. So you need backup. And you need, for these technologies, for AI, you need backup of the backup. And if you allow me, sometimes you need backup of the backup of the backup because the business is not able to be disrupted. And I mentioned electrification, decarbonization, and of course, the third one is the one we're talking about is AI and data centers. So the three of them are very related. Of course, everything in data centers is coming electrified and is decarbonized or with a decarbonization path, but the whole industry. So let's not forget that what is keeping the lights on is existing infrastructure that needs to be electrified in many cases in the industries, and the power generation needs to be decarbonized in many areas. Still, we have places in Europe that are using coal-fired power plants. By just moving from coal to gas, you would reduce 60% of the emissions, so you would go down to a bit more than 38% by changing to gas, and then you start to implement hydrogen replacing gas. But of course, when you put your gas power generation with wind, with solar, then your emissions are going down. So the perfect storm, Philip, the perfect storm with a lot of technology in the back. And well, it's a game of scale and a game of gigawatts, not so much about gigabytes anymore. So
Yeah, and I guess just to sort of add to the picture, AI clearly it requires a lot more power than traditional workloads, but I guess I think it also consumes it in what we might call some of it in burst loads. So there are sort of significant spikes in terms of power demands. So that's adding perhaps a further problem for local suppliers. And I guess because data centers are often in clusters, so I mean, is that a significant problem you see that local networks will be putting, not just the general, but the fact that, for an hour a day or whatever it is, there'll be an enormous sort of spike load. Just your thoughts as to how complicated that situation is as well.
I mean, the quick answer is definitively. So there is we are talking about very dense, very intense, very concentrated centers of demand of electricity, which on top of that require an instant response. So you are not able to wait. You're not able to wait minutes or in sometimes hours or even seconds. So you need in the millisecond to be able to ready to ramp up and fill that spike in demand or peak in demand. And well, that's why the thermal power generation with the carbonization solutions, the thermal power generation that can provide all the system services, that can provide balancing, that can make sure that you have that 99.999 eternal period availability is fundamental. And that's why we see the demand for power generation technologies which are reliable, efficient. So, I mean, as the one I have in my back, I mean, the advanced class gas turbine, I mean, has never been so high as it is now. So, I mean, we see demand over that is around 50%, 50% larger than it was 2 years before. And we see it's not stopping and it's really coming from that extreme necessity of smart electricity. Smart means very quick, very reliable, always available, and without the decarbonization path needs to be with the lowest emissions possible and needs to be an enabler of more wind and more solar. Let's not forget that wind and solar, without the backup and the complete picture in the grid is not going to be working as a baseload. So that's why we definitively see the challenge, but the technical solution exists, and they say the endeavor is endeavor of times, endeavor of scales, and endeavor of volumes. So when do we need all these volumes? And well, I think the technology companies were quite busy. We're already for 2 years, we are quite busy, which is great news, but we know that the coming 2 years we're going to be much more busy. And we almost don't want to think what will happen in 5 years from now, but that's for another chapter. So.
No, that's fine. And I know you obviously you say you've been very busy, and you're suggesting that the energy mix needs to change. I mean, I think you've alluded to it already, but and in particular, you think there's a role to play for gas turbines and gas blended with hydrogen as a source as the source fuel. So just please share sort of what you've been doing in that area.
No, absolutely, absolutely. I tell you that I mean, gas is the fuel, the transition for 100% renewable or zero carbon future. I mean, we need it. We need it now. We need it the coming 2 years, the coming 4 years, the coming 5 years. Let's not forget that this is not a battle between renewables or gas. I mean, renewables without gas cannot be integrated in the grid. That is the reality in every country. There are, of course, exceptions that are especially due to hydropower plants that can do exactly the same job as gas turbines. But what we are seeing is that still over 20% of the global power generation is coming from coal. And by replacing coal with gas, so over 20% of that global power generation, we could reduce over 60% emissions, over 60%. That's what we would call a very heavy transition step. But not only 20%, over 20% in coal, there is over 20% in liquid fuel. So let's look at the whole pie chart of power generation globally. There is over 20% as well of power generation coming from liquid fuels, fossil fuels like diesels, that can easily be transformed into gas. And when we talk gas, can be gas, the methane, the natural gas, but can be gas blended with hydrogen, can be gas blended with ammonia, can be ammonia as well, and can be hydrogen as well. All the gas turbines that we are deploying are already prepared for minimum 30% blended hydrogen, and we are coming out with 50% now. We have already tested and validated it, and very soon we will come with 100% hydrogen possibility. But always the gas turbine will be available when that electricity available, reliable, solid with all the services is needed. And when wind and solar are ready to dispatch, we will utilize all the wind and solar. So it's a huge, huge step for energy transition to take out coal, to take out liquid fuel. You would reduce the emissions to less than one third of where we are today. And well, you will be able to implement much more solar and much more wind. And again, data centers, electrification, certain critical processes in the industry, they rely on this reliable, sustainable, but all the time available power plants. And that's why society has decided that we need more electricity. We have the most reliable, the most advanced, fast response technology, which, yes, it is using gas, but again, it's already starting to be blended. We have already power plants in the UK, in the States, where we're already blending with hydrogen. And well, we are eliminating completely the carbon and the greenhouse emissions. It's a matter of having a good mix of power generation, and yes, take out the coal and take out the oil from power generation.
Okay, yeah. I mean, you mentioned that you're already doing it in the US and the UK. And in terms of hydrogen, I mean, I'm interested in hydrogen because, as I understand it, the major problem at the moment, in a lot of countries, it's not available on a sort of industrial scale. So that's the problem. And I know there's also issues potentially as to the way hydrogen is produced, green hydrogen as opposed to not. So, and then my friends that work in the car industry, just to complete the picture, reckon that we won't have EVs will eventually go to hydrogen. But so I don't know if you have any thoughts or you're happy to share any thoughts as to how significant you think hydrogen will be, into the future when it comes to power.
Absolutely. No, thank you. Thank you for that, Philip. Definitively, we have made a decision as planet, as human race, human society to electrify for emissions, for smartness, for availability, for quality. We're elevating the quality of all the technology we have, and that requires that there is molecules that are able to transport electricity. Just to give a clear example, in this length of a cable is able to transport less than 1/10 of the energy that you can transport in a pipe of the same length. So when you transport energy in a vehicle like a molecule can be gas, natural gas, can be ammonia, can be hydrogen. You are able to transport. You are going to be much more efficient by just deploying cables everywhere. So you need to use cables when needed. You need to use piping when needed. We have already pipes. We have pipelines that can be used and can be blended already with hydrogen. We have already cables. All the infrastructure in places like the UK, EU, or the US is quite agey. I mean, it's over 40 years of age. So there's a lot of retrofitting investment required to be able to cope with the additional demand. So we need to make very smart decisions. One of them is just blending. Blending is a very clever one. So the gas infrastructure is there, the power plants are there. So I tell you, all the installed power plants that are keeping the lights on globally can already adopt a big amount of hydrogen. So from 5 to 10 to 20 to 30% can be already implemented in the existing power plants. So there is not a big investment to be made. So that would reduce the emissions quite considerably just by doing that. Hydrogen, indeed, the volumes of hydrogen are in the early phase of this of the massive use of this molecule. But well, 25 years ago, yeah, 25 years ago, even 20 years ago, solar panels were extremely expensive, and we needed volumes of scale, mass production to, and well, places like China that produce incredibly efficiently reduce the prices and the cost by 90%, and then solar industry started to shine, and not very different happened with wind 15 years ago. So scales, volumes, and production capacities going up gets the prices down. With batteries, we have seen over the last 10 years that battery prices were expected to go down, didn't. But after the last 2 years, it has started to go down radically due to volumes, due to scales, and of course, due to EV industry, to automotive industry, but also the utility scale battery. And for molecules, for hydrogen, the hydrogen viability financially depends on the equipment. So getting green hydrogen depends on equipment that needs to be produced at a scale. So electrolyzers of different technologies from uh, PEM systems, different. We are looking at pyrolysis technologies. We are looking at different types of production of hydrogen, also in Mitsubishi Power and Mitsubishi Heavy Industries, producing hydrogen with the most commercial potential to become the lowest cost per megawatt hour stored in the molecule. To achieve that, to succeed on that, you need scale, you need volumes, you need mass production, and that's in the journey in which we are already embarked. So something that we see, those who have a bit of gray hair already, that the level of patience is going down with the years. So I think nobody would have given up solar. We saw solar is a very inefficient technology. It has very low ratio from photon to electron, but it's a very, very low cost production of electricity. You need a lot of space to deploy it, but it makes sense because of the super tiny cost of production. Well, the same happens when you go with a scale with wind turbines. It happened the same with our gas turbines 30 years ago. I mean, at the beginning, gas turbines, a combined cycle was a totally luxurious technology, closer to nuclear than what it is today. Today is behind I mean, it's almost a behind the meter technology. We can deploy a gas turbine in a modular fashion very quickly. Of course, we need to have the production capacity to respond to the demand. So to your question, Philip, yes, we see hydrogen, we see low carbon or zero carbon molecules being taking a very, very significant role. Data centers, AI, they need firm power. Firm power needs to be guaranteed power, insured power. And to get insured power, you cannot rely on solar or in wind power. So you need to rely on a mix that is totally guaranteed. As I said, renewables plus the backup of the backup. And that's involving technologies like the one I have here in my right hand. So it's the most advanced, the most efficient, the la crème de la crème of the technology that engineering, human technology has achieved. But again, the emissions turbine is not linked to the molecule. You need a molecule, and that molecule, if it's a fossil molecule, it will have the C of the carbon and will get carbon emissions. And I will close it by saying, as you know, that there are other, in the case that you are not able to completely eliminate the emissions in your power generation, you have the ultimate bullet, which is the carbon capture and storage, so that you and utilize that carbon. So we have that technology that is already industrial, is being deployed at large scale, is part also the portfolio of our group of Mitsubishi Heavy Industries, where when you have a process, of course, very typical steel mills, cement plants that you need to produce them with certain processes, well, you can still eliminate or contain all the emissions by that final technical solution. But just to your point, electrification, gas is the transition fuel, and hydrogen is the molecule that will come in the future with us as a mainstream.
Yeah, and in terms of, I mean, obviously data centers, we're talking about the renewable side of things, but I guess data centers also have the opportunity to use the power that is supplied to them in more efficiently. I think you referenced earlier cooling systems, and clearly there's a trend from air cooling to liquid cooling. And then I guess energy management is an area where perhaps data centers aren't as advanced as they could be. And I guess even, I mean, the folks that are developing the AI chips are obviously trying to make those more efficient. And I guess just your thoughts as to how, we've talked about the renewables side of things, but what else can data centers do, and how significant is it, some of those things I've mentioned, the cooling, energy management, in terms of helping them address their carbon footprint, if you like.
No, thank you, Philip. I have to say that the cooling is as relevant as the energy part. And when at the end, cooling, let's not forget, is removing the heat to cool down. I mean, it's a heat transferring process, very something invented centuries ago, at least patented in the UK. And definitively, we're in the start of the journey. We're still in the start of the journey. At Mitsubishi, we have already launched a business. A new division called Data Centers and Electrification, and Energy Management is included there. So where you are emissions and reliability and efficiency, you can affect them not by changing the technology or by changing the molecule. So you can also achieve it by improving the efficiency and improving the management of the assets that you have. So smartness, getting brain inside. So getting the AI to manage the AI data centers is a fundamental step that is gonna come. I mean, that we are gonna be wasting less, which wasting less means removing fat and removing emissions out of the system. So that's why we have the hope that we will not have to just simply multiply all our capacities to respond to all the humongous unprecedented demand, but also the demand will rationalize because it will become more efficient. We will be able to need less cooling, or the cooling will be more capable, and at the same time, the electricity, the way that the system are being operated, so the thermal power with the storage, with the grid, with the renewables, the way this is being played, you can play it always better. That you squeeze much more value from the assets that you have, and that's part of this business that we have, this data center and energy management in Mitsubishi, and that the society and the data centers developers are already working in is how to get the data centers bigger and get to this hyperscaling and also benefit from these additional sizes. So size matter in these cases enormously. So the bigger systems you have, the more you can play with efficiencies, with closing cycles, etc. So at the end, last century, market started with the combined cycles, which was doubling the efficiency of the power plants by repurposing the heat that was being dumped into the atmosphere. This is, I would say, not as simple as that, but not much more complicated. So it's really, when you cool something, you need to be able to use that heat that you're extracting for another purpose. And that's what we are working on, and definitely what industry has been doing in the past. data centers is becoming a huge industry by itself, and will have that learning curve and that implementation curve. But again, in the coming 2 to 5 years, the road is very clear. We know that in the year five, we will have a lot more gadgets and tools and learnings, and especially the scale will give us that potential. When you have a scale enough, you are able to move the needle much better in innovation and in improvement of the existing systems.
Yeah, and maybe just back to data centers in terms of, I mean, power purchase agreements obviously exist and achieve a certain amount, but do you think we need to move beyond the sort of standard ones to encourage the data centers to work with partners to integrate on-site generation, battery storage, intelligent energy management? What do you think needs to be done there? And I mean, again, how does that happen? Is there a way of making them do it, or do they just need to understand that it makes more sense than their sort of current approach, if you like?
Yes, yes. No, definitely data centers should not be considered as business as usual, and getting one data center deployed in location X, location Y, location Z. No, there is an absolute need of having a total view of what is going to be the data center necessity, needs, where is the best location, where you can have more renewable power, where do you have the space, where do you have the connectivities and the cables, but cables from data, but cables from electricity, piping from molecules, etc. So you need to plan it, and PPAs and project development is working in the very early phase of this new era of AI. But in the second phase, which is still the infancy of AI, we better have a very smart view of all what's going on. If not, we're going to be wasting resources and placing data centers and placing centers where they are not needed, or causing enormous collapses. So you can imagine when you have a data center, and I will not say the name of the country, but in a desert place in a central part of a country, and the country has a total blackout, and well, you data center cannot lose the electricity. So what's going to happen? Data center is going to absorb all the electricity available, and it's going to keep all the processes. So there is a need of strategizing where they need to be, what backups need to be, and not acting like a industry, a factory being placed there, because it's not a factory. It's the subordinates of a data center are enormous in terms of if you are creating for power companies, not us, but for our customers, for utilities, is the golden customer. Is one customer in one location having huge necessity and constant. Not going for holidays is always is fantastic. But for the society living not far from it is not fair. It's like having, I don't know, Real Madrid and then all the second division playing around. So you know who's going to win all the matches. So it's you need to have a bit of a balance, or make the decision. Okay, these people are going to play in this level of security, and we need to maintain the level of security of everybody else. So that's why the backup, the reliability, and that's why well, as mentioned, gas turbine is having the largest demand ever in history, and is going to continue for many years to come, and well, we are ready. We're ready.
Yeah, I guess I have to. I think you mentioned that at the fairly near the beginning of the interview, you are an optimist. But I mean, bearing in mind, I mean, there's some significant challenges. Are you confident that what needs to be done will be done in the right time frame, or do you worry that there might be sort of in the short term, at least, more sort of blackouts and incidents? But
I mean, let's say that the blackouts and incidents is when we are growing the need of electricity so massively, and while more wind and solar are coming into the grid. I mean, again, the mention before about technology over ideology is quite important. So systems have all the means not to have blackouts, not to have outages, especially in the places where they happen recently. But you need to manage well. I mean, you cannot make decisions that disable backups or disable security or safety. So, but we are coming into times in which electricity demand is growing, renewable penetration is growing, and there are, on top of that, there is coming big centers of demand that require electricity all the time to be guaranteed, to be safeguarded. So, well, we need to plan well, and we need to be cool, and we need to be pragmatic, realistic, and honest. Those three things, the basics of engineering. So if we do that, so if we have engineers in the decision places, it will work well. So it's not because I want to be there. I just want to be a good citizen and enjoy the service.
Well, that's brilliant. It's been so great to chat, and thank you for sharing so many brilliant insights. So, Javier, thank you very much. Thank you.
Thank you, Philip. It has been my pleasure, and speak to you soon. All the best.